Have you ever paused just for a moment and wondered whether everything you think you know about the universe is shaped not by what is out there, but by what you are allowed to see? I mean, when you look at those breathtaking images of galaxies and nebulae glowing like cosmic fireworks, you might feel, well, that sense that we've done it, that humanity has finally lifted the veil and gazed across almost all of existence. And that's the thing, you see, our brains are rather easily convinced by beauty. A handful of luminous pictures, carefully colored and framed, can give the quiet illusion that the universe has been mapped, measured, almost tamed. But perhaps, and this is where it becomes unsettling, the real question is not what we have seen at all. Perhaps the deeper, more honest question is what we have never seen, and may never see. Imagine standing on a beach at night, the ocean stretching endlessly into darkness. You can hear the waves, you can feel the breeze, but your torch only lights a few meters ahead. Would you ever claim to know the entire sea? And yet that is very close to how we approach the cosmos. The universe may be vast beyond comprehension, and our understanding, well, astonishingly small, like a candle flickering in a cathedral the size of eternity. This is the central paradox, I suppose, the one that should make us feel both humble and quietly amazed. The universe is immense, almost unimaginably so, and our knowledge of it is, in truth, a fragile island surrounded by an ocean of the unknown. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So, let's continue. If I were to ask you, quietly, gently, how big the universe really is, you might hesitate for a moment, and then perhaps recall a number you once heard. Something vast, something almost theatrical in its scale. 93 billion light-years across, you might say, and you would not be wrong, not exactly. But you see, and this is where it begins to feel strange, that number does not describe the universe itself. It describes a boundary drawn not by space but by time, by the simple and unforgiving fact that light, even at its astonishing speed, has only had so long to travel. And so when we speak of the size of the universe, what we are often really describing is the size of our vision, the reach of our cosmic eyesight, rather than the true extent of everything that exists. Imagine, just for a moment, that you are standing in a vast field at night. There is no moon, no artificial light, only darkness stretching in all directions. You strike a match, and for an instant, the world appears. A few blades of grass, the ground beneath your feet, perhaps the faint outline of something nearby. When the flame dies, the darkness returns. The field did not shrink when the light went out, and it did not grow when the match was lit. Only your awareness changed. In much the same way, the observable universe is that brief circle of illumination defined by how far light has managed to reach us since the beginning of cosmic time. The number itself, 93 billion light-years, already sounds impossibly large, and yet it hides a deeper subtlety. The universe is not static. Space itself stretches, expands, carries galaxies away from one another like dots painted on the surface of an inflating balloon. The light we now receive from the most distant galaxies did not travel through a fixed stage. The stage was moving, growing, expanding beneath its feet, so to speak. And so the edge of the observable universe lies much farther away today than the simple age of the universe multiplied by the speed of light would suggest. It is a reminder, you know, that our everyday intuitions are poorly suited to cosmic scales. Space and time are not separate boxes. They are woven together, inseparable, shaping what we can see and what must remain hidden. But here's the crucial thing, and it is easy to miss. That immense sphere we call the observable universe is not the whole story. It is not the full extent of reality. It is merely the region from which light has had enough time to arrive at our small planet since the universe became transparent. Beyond that horizon, There may be more galaxies, more stars, more patterns of matter arranged in ways we can scarcely imagine. Or perhaps something even stranger. The laws of physics might hold steady, repeating endlessly beyond our view, or they might shift subtly, giving rise to regions fundamentally different from our own. The truth is, and this is both humbling and thrilling, we simply do not know. And I suppose this is where a quiet kind of humility enters the conversation. For centuries, human beings have struggled against the idea that we are not central, not privileged observers of the cosmos. First, we learned that Earth is not the center of the solar system. Then, that our sun is just one star among hundreds of billions in a single galaxy. And later still, that our galaxy itself is just one among trillions scattered across the observable universe. Each step has gently pushed us further from the center of the picture. And now, when we speak of the observable universe as though it were the universe itself, we risk making the same mistake again. We confuse the limits of our perception with the limits of existence. There is something almost poetic about that boundary, the cosmic horizon. It is not a wall in space that one might crash into. It is not a curtain hiding something just beyond reach. It is a boundary in time, a reminder that the universe has a history, and that we are embedded within it. Light from beyond that horizon is not blocked or destroyed. It simply has not arrived yet, and perhaps it never will. As the expansion of space accelerates, driven by something we barely understand, regions that are currently visible may one day slip beyond our observational reach. Their light, emitted in the far future, will never reach us. They will fade, not because they cease to exist, but because the universe itself carries them away faster than light can bridge the gap. When you think about it that way, the observable universe becomes less like a map of everything and more like a fleeting snapshot, a momentary glimpse shaped by cosmic timing. We are not seeing the universe as it is now. We are seeing it as it was, layered in time. Nearby stars appear almost as they are today, but distant galaxies are seen as they were billions of years ago, when the universe was younger, denser, more chaotic. Look far enough, and you approach the moment when the first stars ignited, when darkness gave way to light for the very first time. Beyond that, there is a veil we cannot penetrate directly, a fog of primordial plasma that scatters light and hides earlier moments from view. And so, even within the observable universe, our vision is incomplete. We do not see a single moment spread across space. We see a vast archive of cosmic history stretched across the sky. Every direction you look is also a direction back in time. That thought alone, I suppose, should make us pause. The universe is not just big in space. It is deep in time, and our observations are always entangled with that depth. Now consider what it means to ask how big the universe truly is beyond what we can observe. Some models suggest that it could be vastly larger than the observable region, perhaps hundreds or thousands of times bigger. Others allow for the possibility that it is infinite, extending endlessly beyond any horizon. If that is the case, then the observable universe is an infinitesimal patch, a tiny bubble within an unbounded expanse. Our entire cosmic story, every galaxy we have ever photographed, every star whose light has touched our instruments would be a vanishingly small fraction of what exists. And yet, and this is important, science is not defeated by that ignorance. It does not retreat in the face of the unseen. Instead, it learns to ask careful questions, to infer the nature of what lies beyond our view, by studying what we can observe with exquisite precision. The uniformity of the cosmic background radiation, the distribution of galaxies on the largest scales, the geometry of space itself, all of these whisper clues about the larger structure of the universe. They suggest, at the very least, that what we see is not special, not unique, but part of something much grander. Still, there is a line we cannot cross. No telescope, no matter how powerful, can look beyond the observable universe. This is not a technological limitation in the usual sense. It is a fundamental one. It is written into the fabric of space-time, and I find that strangely comforting. There is something deeply human about living with boundaries, about knowing that some questions may never have direct answers. It reminds us that science is not a quest for omniscience, but a disciplined way of listening to what the universe is willing to tell us. As we sit here, on this small rocky world orbiting an ordinary star, the vast majority of the universe may forever remain beyond our direct experience. Entire regions of space may exist that will never influence us, never send us a single photon, never leave a trace in our detectors. They are causally disconnected, not because they are unreal, but because the universe is simply too big, too dynamic for everything to be connected to everything else. And that realization naturally leads us to another, equally unsettling thought. Even within the region we can, in principle, observe, there are strict limits imposed not just by distance, but by the very nature of light itself. Because light does not travel infinitely fast, because it carries information at a finite speed, there are horizons not only in space, but in time. To look farther is always to look earlier, and to accept that some information has not yet had the chance to reach us. And so, as we begin to grasp the true scale of the universe, we are gently guided toward the next question, the one that follows almost inevitably from the first. If the size of the observable universe is defined by the journey of light, then what exactly are the limits of that journey? And how does the finite speed of light shape everything we can know about the cosmos? And so, having arrived at that quiet realization that the size of the universe is written not only in space, but in time, we are led almost inevitably to the question of light itself. Because everything we have just spoken about rests on a single, deceptively simple fact. Light does not travel infinitely fast. It moves quickly, astonishingly quickly, faster than anything else we know, and yet it has a speed, a limit, a ceiling written into the fabric of reality, and that limit shapes everything we can ever know about the cosmos. You see, in everyday life, light feels instantaneous. You switch on a lamp and the room fills with brightness without delay. You glance at a distant hill, and it appears there, fully formed, as though no time has passed at all. Our senses evolved in a world where distances are small enough that the finite speed of light goes unnoticed. But the universe is not scaled to human intuition. On cosmic distances, light becomes a traveler, a messenger crossing immense gulfs of space, carrying news from distant places at a pace that, while fast, is still bound by time. And that's the thing. You know, the moment you accept that light has a finite speed, you also accept something far more unsettling. To look far away in the universe is to look backward in time. There is no other way it can be. The light leaving a distant galaxy began its journey, long before our planet even existed in its current form. When it finally arrives at Earth and falls into the mirrors of our telescopes, it is already ancient. We are never seeing the universe as it is right now. We are seeing a mosaic of different eras layered across the sky. Perhaps it helps to think of it like listening to echoes in a vast canyon. A shout bounces off the walls and returns to you moments later. The sound you hear is not happening now. It is a memory, a delayed impression of an event already gone. The deeper the canyon, the longer the delay. The universe is the deepest canyon of all. Every photon that reaches us is an echo, telling us a story about what once was, not what is. When you gaze at the sun, you see it as it was a little over 8 minutes ago. That seems trivial, almost negligible. But look at the nearest star beyond the sun, and you see it as it was years in the past. Look at the center of our galaxy, and you peer tens of thousands of years back in time. Beyond our galaxy, the delays stretch into millions and billions of years. Some of the galaxies captured in our deepest images no longer exist in the form we see. They may have merged, transformed, or faded into something entirely different. The light we collect is a fossil record, a cosmic archaeology written in photons. And then there are regions so distant that their light has not yet reached us at all. This is not a failure of our instruments or a temporary blind spot waiting to be solved by better technology. It is a fundamental consequence of time itself. The universe has a finite age, and light has only had that much time to travel. Beyond a certain distance, there simply has not been enough time since the beginning for any signal to arrive. Those regions are real, if they exist, but they are causally disconnected from us. They are outside our observable reach, not because we lack curiosity or ingenuity, but because the universe has drawn a line we cannot cross. This realization gives rise to what cosmologists sometimes call an observational wall, not a physical barrier, not a boundary you could point to in space, but a horizon defined by the journey of light. No matter how powerful our telescopes become, they cannot collect photons that have not arrived. You cannot speed up light by building a bigger mirror. You cannot peer past a horizon that is defined by the age of the universe itself. In that sense, the cosmos has built-in limits, rules that even the most advanced civilizations must obey. There is something quietly profound about that. We live in an age of extraordinary technological confidence. We send machines to other planets. We detect ripples in space-time itself. We decode the chemistry of stars billions of light years away. And yet, despite all this, there are parts of the universe that are, in principle, unreachable to our eyes. They will never be photographed. Their light will never warm our detectors. They exist perhaps in a permanent silence relative to us. And still, our minds have a habit of resisting this idea. We are storytellers by nature. We like beginnings, middles, and ends. We like to believe that with enough effort, enough patience, every mystery will eventually yield. But the finite speed of light teaches us a different lesson. It tells us that knowledge is local, constrained, shaped by the conditions of observation. We are embedded observers, not detached gods, surveying everything from above. This also means that the universe we reconstruct in our theories is always an interpretation. We infer what lies beyond our horizon by studying the patterns within it. We look for uniformity, for symmetry, for clues written in the oldest light we can see. But inference is not the same as observation. It is a careful, disciplined form of imagination guided by evidence. And while it has served us remarkably well, it always carries an element of uncertainty. There is another subtle consequence of the finite speed of light, one that often goes unnoticed. Because information cannot travel faster than light, cause and effect are limited by this cosmic speed limit. Events happening far away cannot influence us instantly. The universe is stitched together by light and other signals that move at finite speeds. This creates a structure of causality, a cosmic order in which not everything can affect everything else. Some events are simply too far away, too separated in space-time, to ever matter to us. In a strange way, this gives the universe a kind of intimacy. Our cosmic neighborhood, the region of space that can influence us and that we can influence in return, is finite. It is vast by human standards, unimaginably so, but it is not infinite. Beyond it lies a realm that is effectively separate, a parallel expanse of existence unfolding without any connection to our story. And yet, when we look up at the night sky, it does not feel that way. It feels whole, complete, overflowing with stars. Our senses betray us again. The darkness between the stars looks empty, but it is filled with distance and delay. Each point of light is a different chapter in a cosmic history book, written at a different time, sent to us across different spans of space-time. As telescopes grew more powerful, we learned to look deeper, and with each leap forward, the universe appeared younger, hotter, more turbulent. We pushed closer and closer to the beginning, until we reached a point beyond which light itself could not travel freely. Before that era, the universe was opaque, a dense fog of charged particles scattering photons in every direction. Light could not move unimpeded. There was no clear view, no transparent window. And so, even though the universe existed before that time, it left no direct visual record we can observe. That, too, is a limit imposed by light. Not just its speed, but its interaction with matter. The universe had to cool, to thin out, to become transparent before light could begin its long journey to us. Everything earlier is hidden behind that veil. We can model it, simulate it, infer its properties through subtle imprints, but we cannot see it directly. So when we talk about the observable universe, we are really talking about a layered structure of limitations. Limits of time, limits of speed, limits of transparency. Each one carves away a portion of reality and places it beyond our reach. And yet, within those limits, there is an extraordinary richness. The fact that we can see anything at all, that light has carried the story of the cosmos across billions of years to arrive here, is nothing short of miraculous. I suppose this is where the emotional weight of cosmology quietly settles in. The universe is not obligated to be understandable. It does not owe us clarity or access. And yet, through the humble medium of light, it has given us glimpses of its history, its structure, its evolution. We are like listeners catching fragments of a vast symphony, hearing echoes drifting across unimaginable distances. As we begin to accept these limits, another realization starts to emerge, almost gently. Even within the light that does reach us, even within the observable universe itself, our eyes are far from sufficient. Light comes in many forms, many energies, many wavelengths, most of which our biology cannot perceive. And so the next boundary we must confront is not written in the cosmos alone, but in ourselves, in the narrow window of reality that human vision allows us to experience. And so, as we come to terms with the idea that light itself limits what we can know, another, quieter boundary begins to reveal itself. Even when light does reach us, even when it has crossed billions of years to arrive here, there is no guarantee that we can truly see it. Because the truth is, and this often surprises people, the human eye is astonishingly narrow in what it allows us to perceive. We like to think of vision as a window onto reality, but in truth it is more like a keyhole, offering only a thin sliver of what is actually there. You see, the light that fills the universe comes in many forms. It stretches and compresses, vibrates and oscillates across a vast range of energies. But our eyes are tuned to just a tiny band of that spectrum, a narrow ribbon we call visible light. It is no accident, of course. Our vision evolved under the light of a particular star on a particular planet, surrounded by a particular atmosphere. The sun emits most of its energy in this range, and so our eyes adapted accordingly. Useful, practical, beautifully efficient for survival on Earth. But cosmically speaking, profoundly limiting. If you could step outside your biology for a moment, if you could somehow see the universe in all its wavelengths at once, the night sky would no longer look dark and empty between the stars. It would blaze with structure and motion. Great rivers of radio waves would flow between galaxies. Clouds of cold gas would glow softly in infrared. Violent regions around black holes would flare in X-rays. Gamma rays would mark the most extreme events in the cosmos, explosions so powerful they briefly outshine entire galaxies. All of this is happening constantly, everywhere, and yet to your naked eye, it is utterly invisible. And that's the thing, you know. When we say we are looking at the universe, we are really saying we are interpreting it through layers of limitation. First, the finite speed of light. Then the narrow sensitivity of our senses. The universe does not privilege human perception. It does not arrange itself conveniently around what we can see. It simply is, vast and complex, radiating information across the entire electromagnetic spectrum. For most of human history, this invisible universe might as well not have existed. Our ancestors looked up and saw stars, planets, a faint milky band across the sky. They built stories, myths, calendars, all of it based on that thin slice of light their eyes could detect. And even today, when we scroll past stunning astronomical images, it is easy to forget that these pictures are not what the universe looks like. They are translations. Modern telescopes are not just bigger eyes. They are interpreters. They listen to the universe in languages we cannot naturally understand and convert those signals into something we can see. A radio telescope does not take a picture in the ordinary sense. It measures faint oscillations in electric fields caused by long wavelength radiation. An X-ray telescope does not see in the dark the way a cat does. It detects high-energy photons that would pass straight through your retina without leaving a trace. Infrared observatories capture heat signatures, the gentle glow of cool objects that emit almost no visible light at all. When scientists assign colors to these observations, they are making choices. They map invisible wavelengths onto visible hues so that patterns emerge, so that structure becomes comprehensible. The swirling reds and blues of a nebula, the delicate filaments glowing in false color. These are not deceptions, but they are not literal views either. They are data rendered into a visual language our brains can process. And that subtle distinction matters. What we call images of the universe are, in truth, carefully crafted translations of something fundamentally beyond our senses. This has a curious psychological effect. Because the images are beautiful, vivid, and detailed, they give us a sense of completeness. We feel as though we are seeing everything, as though the cosmos has been laid bare. But in reality, we are still peering through filters, layers of interpretation stacked upon layers of limitation. The universe we picture in our minds is already a reduced version of something far richer and more complex. Even with invisible light itself, there are things we miss. Dust clouds can block our view, hiding entire regions of star formation. Gas can absorb certain wavelengths, erasing information before it ever reaches us. What appears empty may be full of matter too cold or too diffuse to shine visibly. Darkness in astronomy does not always mean absence. Often it simply means invisibility. And so, as our instruments improved, a quiet revolution took place. Astronomers learned to stop trusting their eyes alone. They began to listen to the universe across the full spectrum. Suddenly, familiar objects looked completely different. A galaxy that appeared serene in visible light might reveal violent jets of particles when observed in radio waves. A calm-looking patch of sky might erupt with X-ray flares, signaling the presence of a supermassive black hole feeding at its core. The universe, it turned out, had been far more active, more dynamic, more energetic than it ever appeared to the naked eye. This realization carries a deeper implication. If most of the universe does not emit visible light, then most of the universe has always been hidden from our direct experience. We evolved in a luminous bubble, surrounded by a sea of invisible phenomena. Our sense of reality, our intuition about what exists and what matters, is shaped by this narrow window. And stepping beyond it requires humility. It requires us to accept that reality is not obligated to be intuitive. Think for a moment about how strange that is. The vast majority of what the universe does is invisible to us. The slow collapse of cold gas clouds, the whisper of radio signals drifting across intergalactic space, the searing radiation from regions near neutron stars, all of it unfolds whether or not we have the tools to detect it. Our discovery of these phenomena did not bring them into existence. It merely brought them into awareness. And yet, even with our most sophisticated instruments, we are still interpreting shadows. A radio signal becomes a map. An X-ray detection becomes a false color image. A spectrum becomes a graph of peaks and valleys that we learn to read like a language. We do not touch the universe directly. We infer it. We reconstruct it. We build models that explain how invisible processes give rise to the signals we measure. There is something almost philosophical in this. Knowledge of the universe is not a matter of direct sight, but of careful inference. We never observe a black hole itself. We observe stars orbiting something unseen. We observe disks of glowing matter heating up as they fall into darkness. We conclude that a black hole must be there. In the same way, much of what we know about the cosmos comes not from seeing, but from understanding patterns in what we cannot see. And that brings us to an even more unsettling thought. If our eyes miss most of the electromagnetic spectrum, what else might we be missing entirely? There are messengers other than light, particles that pass through matter almost without interaction. ripples in space-time itself, signals so elusive that they require enormous detectors buried underground or floating in the depths of space. Each new window we open reveals a universe subtly different from the one we thought we knew. Yet, despite all this complexity, there is a strange coherence to it. The universe speaks in many voices, but they tell a consistent story. The radio waves, the infrared glow, the visible light, the X-rays, all fit together like pieces of a grand puzzle. Each wavelength reveals a different aspect of the same underlying reality. And by learning to listen across this spectrum, we slowly assemble a richer picture of the cosmos. Still, it is worth lingering on the emotional weight of this realization. Everything you have ever seen with your eyes is only a fraction of what exists. The night sky, as beautiful as it is a deeply incomplete portrait of reality. The universe is not just bigger than we imagined. It is stranger. It operates on scales and in forms that lie far beyond our natural perception. And perhaps that is why astronomy has always carried a sense of wonder mixed with humility. Each technological advance reveals not closure, but depth, not final answers, but new layers of mystery. We build better instruments, and the universe responds by showing us how much more there is to learn. As we begin to appreciate how little of the universe our eyes can truly see, another question starts to take shape. Even with all these tools, even with every wavelength translated and every signal interpreted, how much of the universe have we actually mapped, cataloged, and understood? How much of what exists has truly been observed, rather than inferred or left untouched in the darkness between galaxies? And that question, quietly and inevitably, leads us toward a more uncomfortable reckoning with the sheer smallness of the portion of the cosmos we have genuinely explored. And so, with that quiet understanding that even our most advanced instruments are interpreters rather than windows, we arrive at a question that is perhaps more unsettling than all the others combined. After everything we have learned, after centuries of observation and decades of space telescopes, how much of the universe have we actually observed in any meaningful sense? Not imagined, not inferred, not artistically rendered, but truly mapped and cataloged. And the answer, when you sit with it long enough, is humbling in the extreme. We often speak about galaxies as though they are plentiful, almost familiar. Spiral galaxies, elliptical galaxies, dwarf galaxies, each neatly classified and sorted into catalogs with long numerical names. There are billions of them within the observable universe, we are told, and the number itself sounds triumphant, as though counting alone were a form of understanding. But the truth is far quieter. The galaxies we have directly observed and studied in detail represent only a minute fraction of what is out there. Even within our cosmic horizon, most galaxies are too faint, too distant, too diffuse to be resolved clearly. They exist as smudges, statistical hints, slight excesses of light in deep surveys, rather than well-understood structures. And then there is the space between those galaxies. This is where intuition fails us most profoundly. When we imagine the universe, we imagine islands of stars scattered through emptiness. But the emptiness itself is vast beyond comprehension. The distances between galaxies dwarf the galaxies themselves. Light can travel for millions of years through these regions without encountering a single star. And yet, this intergalactic space makes up the overwhelming majority of the volume of the universe. It is dark, cold, and nearly empty, and because it emits very little radiation, it remains largely uncharted. Our maps of the universe, impressive as they appear, are deeply incomplete. We have traced large-scale structures, filaments of galaxies stretching across hundreds of millions of light-years surrounding enormous voids where almost nothing resides. But these maps are coarse, approximate, built from limited data. They tell us where matter tends to cluster, not what fills every region of space. Vast volumes remain effectively unobserved, not because they are insignificant, but because they are quiet. They do not shout their presence with light or radiation. They whisper, if they speak at all. It is tempting to focus on the luminous highlights, the galaxies blazing with stars, the nebulae glowing in rich colors. These are the parts of the universe that reveal themselves easily. But they are exceptions, not the rule. Most of space is a dim expanse where matter is sparse and energy levels are low. In those regions, even our best instruments struggle to detect anything at all. And so, our cosmic census is biased toward the bright and the dramatic, while the vast, silent majority slips through unnoticed. When scientists attempt to estimate how much of the universe we have truly observed, the numbers become almost absurdly small. Consider not just the count of galaxies, but the sheer volume of space they occupy. A galaxy, even a large one, fills a tiny region compared to the distances separating it from its neighbors. If you were to imagine the observable universe as a vast ocean, the galaxies we have studied in detail would be like a handful of glowing plankton drifting near the surface. The rest of the water remains largely unexplored, and that is not an exaggeration. Even within our own galaxy, there are regions we know almost nothing about. Dust clouds obscure large swaths of the Milky Way, blocking visible light and hiding stars behind thick veils of gas. We infer what lies there through indirect measurements, through radio waves that penetrate dust or subtle gravitational effects. But inference is not the same as observation. Much of our own galactic backyard remains only partially mapped. The situation becomes even more stark when we look beyond the Milky Way. For distant galaxies, we often know little more than their approximate distance, their total brightness, and perhaps a rough estimate of their mass. Their internal structure, their detailed history, their full composition remain mysteries. And beyond those, there are countless galaxies whose light is so faint that it barely registers at all, blending into the background glow of the cosmos. So when we ask how much of the universe we have observed, we must be honest about what we mean by observed. We have detected signals from many regions, yes. We have measured distributions, yes. But detailed high-resolution knowledge is confined to an astonishingly small fraction of cosmic space. Some estimates suggest that the portion of the universe we have directly and thoroughly observed may be less than a millionth of the whole, and even that figure may be generous. This realization challenges a deeply held assumption. We tend to equate seeing with knowing. If we can photograph something, if we can measure its light, we feel we understand it. But the universe resists this simplification. A faint signal does not reveal a full story. A point of light does not disclose the complexity of the processes within. Much of what exists remains unresolved, both literally and metaphorically. There is also a subtle psychological illusion at work. Modern astronomical images are often mosaics, composites built from long exposures and complex processing. They represent hours or even days of collected light compressed into a single frame. When we look at them, we see a dense, richly populated universe. But this density is an artifact of technique. It hides the fact that the raw signals are sparse, that most of space contributes almost nothing to the image. The darkness is real. We simply learn how to reveal faint traces within it. And so, the universe appears more complete than it truly is. Our maps feel authoritative, our catalogs impressive. Yet beneath this confidence lies a profound incompleteness. Entire regions of space have never been examined in detail. Entire populations of faint galaxies remain undiscovered. Entire volumes of intergalactic space are known only through statistical inference. What makes this even more striking is that the parts we do observe are not representative of the whole. Bright galaxies are not typical. They are outliers, regions where matter has collapsed efficiently into stars. Most matter exists in forms and environments that are far less conspicuous. And so, our understanding is shaped by the exceptions rather than the norm. There is a kind of irony here. The universe is dominated by things that are difficult to see. Quiet regions, sparse matter, subtle signals. And yet, our methods and our instincts are drawn toward brightness and clarity. We build instruments to chase light, to amplify it, to turn it into images. But the universe, it seems, prefers subtlety. As we push deeper and survey wider areas of the sky, we do improve our statistical grasp of the cosmos. We learn how galaxies cluster, how matter is distributed on large scales. But these are averages, patterns, abstractions. They do not replace detailed knowledge. They do not tell us what it is like to be in those vast, empty regions. They do not reveal the fine structure of the cosmic web in its entirety. And perhaps that is the most humbling part of all. Even with all our technology, even with all our ingenuity, we are still cosmic amateurs. We have dipped our instruments into a vast ocean and brought back samples, hints, fragments, enough to build theories, enough to inspire awe, but nowhere near enough to claim comprehensive understanding. This does not diminish the achievement of astronomy. On the contrary, it makes it more remarkable. From such limited data, we have constructed a coherent picture of cosmic evolution. We have traced the growth of structure from the early universe to the present day. We have learned how stars and galaxies form and change, but we must never confuse coherence with completeness. As this realization settles in, another question begins to press gently on the mind. If so much of the universe remains unseen even in principle, if the majority of its volume is dark and quiet and poorly mapped, what might be filling that darkness? Not just empty space, but something else. Something that shapes the universe without revealing itself through light at all. And that thought draws us, almost inevitably, toward the shadowy presence that dominates the mass of the cosmos, the unseen substance whose gravity binds galaxies together while remaining invisible to every telescope we possess. And so we arrive, almost reluctantly, at the presence that has been shaping everything we have discussed, quietly and invisibly, from the very beginning. If most of the universe has never been seen, if vast regions of space emit little or no light, then it becomes possible, even necessary, to consider that much of what exists does not announce itself through brightness at all. This is where the story takes on a more shadowed tone, because here we encounter something that outweighs everything we can see, yet refuses to reveal itself directly. This is the domain of dark matter. At first, the idea feels counterintuitive. Matter, after all, is something we expect to see or touch, something that shines, reflects, absorbs. And yet, when astronomers began to measure how galaxies move, how they rotate, and how they cluster, a profound mismatch emerged. The visible stars and gas simply were not enough. They could not account for the gravitational forces holding these vast systems together. Galaxies were spinning too fast. Clusters of galaxies were bound too tightly. According to everything we knew about gravity, they should have flown apart long ago. And that's the thing, you see. The universe was behaving as though there were far more matter present than we could observe. Not a little more. An overwhelming amount more. Roughly 85% of all matter, it seemed, was missing from view. Not hiding behind dust. Not too faint to detect. Simply invisible. Dark matter does not glow. It does not emit light, absorb light, or reflect it. Photons pass through it as though it were not there. You could place a dense clump of dark matter between yourself and a distant star, and the star would appear unchanged. No shadow, no dimming, nothing. And yet, despite this ghostly behavior, dark matter has mass. It exerts gravity. It bends space-time. It pulls on galaxies and shapes the large-scale structure of the universe. We know it is there not because we see it, but because we see what it does. Galaxies rotate in ways that demand additional mass. Light from distant objects bends around invisible concentrations of matter, a phenomenon known as gravitational lensing. Patterns in the cosmic distribution of galaxies reveal scaffolding made of something unseen, guiding the formation of luminous structures like a hidden framework. In a sense, the universe we see is riding on a dark backbone. The stars and galaxies are decorations, luminous froth on a much deeper, darker ocean. Without dark matter, the universe would look radically different. Galaxies might never have formed at all. Matter would have remained too diffuse, too evenly spread. The very existence of stars, planets, and ultimately life may depend on this invisible substance. And yet, despite its importance, we have no direct detection of dark matter. We do not know what it is made of. It is not composed of atoms like the matter we are familiar with. It does not clump into stars or planets. It does not interact with light or electromagnetic forces in any obvious way. It is, in many respects, utterly alien. This creates a peculiar tension in our understanding. Dark matter dominates the mass budget of the universe, and yet it remains one of the greatest unsolved problems in modern physics. We build detectors deep underground, shielded from cosmic rays, hoping to catch the faintest whisper of an interaction. We search in space for subtle signatures of dark matter particles annihilating or decaying. We simulate entire universes on supercomputers to see how dark matter might behave. And still, it remains elusive. What this means, when you pause to consider it, is extraordinary. The majority of the matter in the universe is invisible to every telescope we have, not just unobserved, but fundamentally unobservable by light. When we speak of how much of the universe we have seen, dark matter forces us to confront a hard truth. Even in regions of space we believe we understand, most of the substance there is hidden from view. Think about our own galaxy. The Milky Way glows with hundreds of billions of stars, stretching across the sky in a luminous band. But embedded within and surrounding it is a vast halo of dark matter, extending far beyond the visible disk. This halo outweighs the stars themselves. Our galaxy is not just a collection of shining suns. It is a luminous island embedded in a much larger invisible structure, and this pattern repeats everywhere. Every galaxy we observe appears to sit within its own dark matter halo. Galaxy clusters are bound together by enormous reservoirs of unseen mass. On the largest scales, dark matter forms filaments and nodes, a cosmic web along which galaxies form and evolve. The universe, it seems, is structured by something we cannot see at all. There is something deeply humbling about that. We are creatures of light. Our biology, our culture, our science all began with what we could see, and yet the universe is telling us that light is a poor guide to what matters most. The dominant component of cosmic structure does not shine. It does not announce itself. It simply shapes everything from the shadows. This also means that when we look out into space, even when we think we are seeing matter, we are seeing only a minority component. The bright regions are not representative. They are tracers, markers embedded within a much larger, darker reality. Our maps of galaxies are like maps of city lights seen from orbit. They show where activity is concentrated, but they do not reveal the full mass of the landscape below. And so, when we ask how much of the universe we have observed, dark matter forces us to revise the question entirely. It is not just that we have observed only a small fraction of galaxies or a small fraction of space. It is that even within the regions we believe we have observed, most of the matter remains unseen. Our picture of the universe is incomplete at a fundamental level. There is also a philosophical weight to this realization. Dark matter does not fit comfortably into our intuitive categories. It challenges our assumptions about what it means for something to exist. It reminds us that reality is not obligated to align with human perception. Existence does not require visibility. And yet, there is something quietly elegant about the way dark matter reveals itself. Through gravity, through motion, through structure. It leaves fingerprints rather than portraits. It tells its story indirectly, through the behavior of everything else. In doing so, it teaches us a broader lesson about knowledge itself. That understanding often comes not from direct observation, but from careful attention to effects, patterns, and relationships. Still, dark matter is only part of the story. Even when we account for it, even when we include this vast, unseen mass, the universe refuses to balance its books. There is something else at work, something even more dominant, something that does not merely hold structures together, but pushes them apart. As we look deeper into the expansion of the universe, as we measure how space itself evolves, we encounter a force or phenomenon that is stranger still, one that does not clump, does not bind, but accelerates the cosmos outward, silently and relentlessly. And so, from the shadows of unseen matter, we are drawn toward an even more mysterious presence, one that shapes the fate of the universe on the grandest scales imaginable. And so, from the quiet gravity of dark matter, we are drawn toward something even more elusive, something that does not merely hide in the shadows, but seems to act everywhere at once. If dark matter binds the universe together, then what we encounter next appears to be doing the opposite. It is stretching space itself, gently at first, and then with ever-increasing insistence. This is where the story becomes almost unsettling in its subtlety, because here we are forced to confront the idea that most of the universe is not only invisible, but actively working against our intuition. This is the realm of dark energy. When astronomers first realized that the universe is expanding, it was already a remarkable discovery. Space itself is growing, carrying galaxies away from one another like dots on an inflating balloon. But for a long time, there was a comforting assumption beneath that knowledge. Gravity, we thought, should be slowing this expansion down. The universe began with a tremendous outward rush, but over time, the mutual attraction of matter should act like a brake, gradually reducing the rate at which space stretches. And then, quite unexpectedly, the universe told us otherwise. Careful observations of distant exploding stars revealed something astonishing. The expansion of the universe is not slowing down. It is speeding up. Galaxies are not merely drifting apart. They are being driven away from one another faster and faster as time goes on. Something unseen is pushing on the fabric of space-time itself. That's the thing, you see. To explain this acceleration, scientists were forced to introduce a new component to the cosmic inventory. Not matter, because matter attracts. Not radiation, because its influence fades as the universe expands. Something else entirely, an energy intrinsic to space itself, dark energy. When we take stock of the universe, when we add up everything we think exists, the numbers are staggering. Ordinary matter, the atoms that make up stars, planets, and people, accounts for only a small fraction. Dark matter dominates the mass, but dark energy overwhelms everything else. Roughly 68% of the total energy content of the universe appears to be this mysterious component. The majority of reality is not made of things at all, but of something that behaves like a pressure embedded in empty space. And empty space, it turns out, is not empty. This is one of the most counterintuitive lessons of modern cosmology. Even in regions devoid of matter, space itself carries energy. As the universe expands, more space comes into existence, and with it, more dark energy. The effect does not dilute, it strengthens. The larger the universe becomes, the more dominant this invisible influence grows. What is dark energy, then? That question remains one of the deepest mysteries in science. It could be related to the energy of the vacuum, a concept that emerges naturally from quantum physics. Or it could signal a modification of gravity itself, a sign that our understanding of space-time is incomplete on the largest scales. Or perhaps it is something even stranger, something we have not yet imagined. At present, we do not know. And there is something profoundly humbling in that admission. The component of the universe that governs its ultimate fate, that determines how space evolves, is the one we understand least. We cannot create dark energy in laboratories. We cannot isolate it, manipulate it, or measure it directly in any conventional sense. We know it exists only because of its large-scale effects on the cosmos. Once again, we are in the realm of inference rather than observation. We watch distant galaxies recede. We measure how their light stretches as space expands. We reconstruct the expansion history of the universe. And from that behavior, we deduce the presence of an invisible driver. Dark energy announces itself not through light, not through matter, but through geometry. And that's where the emotional weight of this realization quietly settles in. The universe is not just filled with things we cannot see. It is shaped by forces we barely comprehend. Most of what determines the structure, evolution, and destiny of the cosmos lies beyond direct perception. The visible universe, rich and beautiful as it is, turns out to be a kind of epilogue written atop a much deeper, darker story. There is also a strange irony here. Dark matter, for all its mystery, at least behaves in a familiar way. It attracts, it clumps, it builds structure. Dark energy does the opposite. It smooths, it accelerates, it pulls the universe apart rather than drawing it together. The two unseen components dominate the cosmos, and yet they act in opposing ways. One builds the cosmic web, the other stretches it thinner and thinner over time. As the universe ages, this balance shifts. In the distant past, matter was dominant. Gravity sculpted galaxies and clusters. But as space expanded, matter became more diluted, while dark energy remained constant per unit volume. Gradually, imperceptibly, dark energy took over, and now, in the current era, it reigns supreme. The expansion accelerates, and galaxies beyond a certain distance begin to slip away from us forever, their light stretched and dimmed until it can no longer reach us. This has profound implications for what we can observe. The observable universe is not only limited by the speed of light and the age of the cosmos, it is also shaped by the accelerating expansion driven by dark energy. Regions of space that are visible today may become invisible tomorrow in a cosmic sense. Not because they disappear, but because the expansion carries them beyond our horizon of influence. In time, the universe will grow lonelier. Distant galaxies will fade from view. The cosmic web will thin. Observers far in. The future may look out and see a much emptier sky, unaware of the rich structure that once lay beyond their reach. Dark energy, by accelerating expansion, gradually erases information from the observable universe. And so, when we speak of how much of the universe we have seen, dark energy adds another layer of limitation. Not only is most of the universe invisible in principle, but the portion that is visible is shrinking in a meaningful sense. The window through which we observe the cosmos is not fixed. It changes with time. There is something quietly tragic about that, and also something deeply beautiful. We happen to live at a moment when the universe is old enough to be transparent and structured, yet young enough that much of it remains observable. Our era is a brief intersection between complexity and accessibility. And even so, we see only a fraction of what exists. Dark energy reminds us that the universe is not static, not a stage on which events unfold, but an active participant in its own story. Space expands, horizons shift, possibilities change, and our knowledge is always provisional, shaped by when and where we happen to exist. As we absorb this, another subtle realization emerges. If dark energy smooths the universe on the largest scales, if it drives galaxies apart and stretches space ever thinner, then it must also shape the distribution of matter into vast regions of emptiness. The universe cannot be uniformly filled. It must develop enormous voids, places where matter is scarce and structure minimal. And those regions, immense and silent, occupy most of the volume of the cosmos, waiting for us to consider what it truly means for space to be almost empty. And so, carried outward by the quiet, relentless push of dark energy, the universe begins to reveal a structure that feels almost paradoxical. One might expect that with so much matter and energy spread across such vast distances, space would be filled more or less evenly. But when we look carefully, when we trace the distribution of galaxies across the sky, a very different picture emerges. The universe is not smooth. It is not uniform. It is profoundly lopsided, shaped into filaments, clusters, and in between them, enormous regions of near emptiness. These are the cosmic voids. At first glance, a void sounds trivial, almost uninteresting. An absence. Nothing to see. And yet, these vast regions dominate the universe by volume. They are not small gaps between galaxies. They are immense expanses, sometimes hundreds of millions of light years across, containing very little matter at all. If the galaxies are cities of light, then cosmic voids are the great deserts between them, stretching farther than the imagination can comfortably reach. And that's the thing, you see. When we speak about the structure of the universe, we tend to focus on where things are, the galaxies, the clusters, the luminous knots of matter. But most of the universe is defined not by what is present, but by what is absent. The voids are not rare exceptions. They are the dominant feature of cosmic geography. This uneven distribution arose naturally from the earliest moments of the universe. Tiny fluctuations in density, imprinted shortly after the beginning, grew over time under the influence of gravity. Regions that were slightly denser pulled in more matter, becoming denser still. Regions that were slightly emptier lost matter to their surroundings, becoming emptier still. Over billions of years, this process exaggerated the contrast, carving the universe into a vast cosmic web. Filaments of matter threaded space, intersecting at dense nodes where galaxies cluster, while the voids expanded and emptied. What is remarkable is just how empty these regions truly are. A cosmic void can contain thousands of times less matter than the average density of the universe. Some voids contain a few faint, isolated galaxies, drifting quietly through the darkness. Others are almost entirely barren. Light can travel for millions of years through these regions without encountering anything substantial at all. And yet, these voids are not meaningless gaps. They are an essential part of the cosmic story. They tell us how matter moved, how gravity sculpted the universe, how dark matter and dark energy shaped the large-scale architecture of space. The very existence of vast voids is a clue to the nature of the unseen forces that dominate the cosmos. From our perspective, this creates another profound limitation on what we can observe. Telescopes are drawn to light. They are exquisitely sensitive to brightness, to contrast, to structure. Void regions offer very little of any of these. They are quiet. They emit almost no radiation. They contain little gas, few stars, and almost no dramatic events. As a result, they are among the least studied regions of the universe. Even when we map the large-scale distribution of galaxies, voids appear primarily as negative space. We infer their presence by the absence of galaxies, rather than by direct observation. They are outlined by what surrounds them, like the shape of a bubble defined by the soap film around it. This means that our understanding of voids is inherently indirect, statistical, incomplete. And yet, these regions occupy most of the cosmic volume. If you could drift randomly through the universe, you would spend the vast majority of your time in a void, far from any galaxy, surrounded by darkness and silence. The luminous structures we celebrate are rare islands in an ocean of emptiness. This challenges another deeply ingrained intuition. We tend to equate importance with density, with activity, with brightness. But in the universe, volume matters. And by volume, emptiness wins. The universe is mostly nothing, stretched thin by expansion, shaped by forces that operate over unimaginable distances. There is something quietly humbling about this. Our entire cosmic experience is shaped by living, inside a dense pocket of matter. We are embedded in a galaxy, surrounded by stars, planets, gas, and dust. Our intuition is forged in these environments. But the universe, taken as a whole, is nothing like that. It is dominated by vast, nearly empty regions where very little happens at all. Cosmic voids also serve as laboratories of a sort. Because they are so empty, they are sensitive to subtle effects. The influence of dark energy, for example, becomes especially pronounced in these regions. As space expands and matter thins, voids grow larger and emptier over time. They are, in a sense, where the expansion of the universe is most clearly expressed. And yet, despite their importance, we have barely begun to explore them in detail. We do not have high-resolution maps of most voids. We do not fully understand the few galaxies that reside within them, how they form, how they evolve in such isolation. The silence of these regions makes them difficult to study, and so they remain among the least understood components of cosmic structure. This adds yet another layer to our growing realization. Not only have we observed only a tiny fraction of galaxies, not only is most matter invisible, not only does dark energy dominate the universe, but most of the space itself, the vast majority of the cosmic volume, lies in regions we have scarcely examined at all. The universe is not just unseen, it is unvisited, unmeasured, largely unimagined. There is also a philosophical resonance here. We often think of emptiness as absence, as lack. But in the universe, emptiness is an active outcome of cosmic evolution. Voids are not failures of structure. They are the natural result of gravity and expansion working together over billions of years. They are part of the universe's design, if one can use such a word. Standing back, one begins to see the pattern. Light shows us only a small fraction. Matter itself is mostly invisible. Energy that drives expansion is mysterious. And now, space itself is revealed to be dominated by vast regions of near nothingness. Each step peels away another comforting illusion of completeness. And still, the universe remains coherent. The voids are not random. They fit into the cosmic web with elegance and consistency. Their sizes, shapes, and distribution encode information about the underlying physics of the universe. They whisper clues about the nature of dark matter and dark energy, about the initial conditions of cosmic history. But to hear those whispers requires patience, subtlety, and ever more sophisticated tools. Which brings us, naturally, to another limit we must confront. Even when phenomena exist within our observable universe, even when they emit signals we could, in principle, detect, our ability to observe them is constrained by technology itself. Our instruments are not perfect. They are limited by noise, by distance, by resolution. And so, beyond the natural limits imposed by physics, there are human limits imposed by engineering. The next question, then, is not only what exists, but how well our tools can truly reveal it to us. And so, standing at the edge of these vast cosmic voids, we might be tempted to think that the limits we face are written entirely into the universe itself. Light travels only so fast. Matter hides in darkness. Energy stretches space beyond our reach. But there is another boundary, quieter and more intimate, one that belongs not to the cosmos, but to us. Even when the universe is willing to reveal something, even when signals arrive at Earth after crossing billions of years of space and time, our ability to capture and understand them is constrained by the tools we build. This is where the limits of observation become unmistakably human. We often speak about telescopes with a kind of reverence, as though they were all-seeing eyes peering effortlessly into the depths of space. And indeed, they are extraordinary achievements. Vast mirrors, delicate detectors, instruments cooled to near absolute zero, all working together to catch the faintest whispers of the cosmos. But every telescope, no matter how powerful, is bound by noise. There is always interference, thermal vibrations in detectors, random fluctuations in incoming signals, cosmic rays, striking sensors at inconvenient moments. Even the universe itself glows faintly with background radiation that can drown out weaker sources. The cosmos is not a quiet place, and listening to it requires filtering signal from chaos. Distance compounds this problem. Light spreads as it travels. The farther it goes, the thinner it becomes, until only a handful of photons arrive after a journey of billions of years. By the time that light reaches our instruments, it is incredibly faint. Detecting it requires long exposures, careful calibration, and complex data processing. Even then, uncertainty remains. A faint smudge on an image might be a distant galaxy, or it might be noise masquerading as structure. Distinguishing between the two is a delicate art. And that's the thing, you know. Much of modern astronomy does not involve seeing objects directly in any intuitive sense. It involves statistics. It involves confidence levels and probability distributions. Astronomers ask not whether something is definitely there, but whether it is likely there given the data. The universe becomes a puzzle assembled from incomplete pieces, guided by models and assumptions. Resolution is another constraint. No matter how large a telescope becomes, there is a fundamental limit to how finely it can distinguish detail. Objects that are too small or too distant blur together. Entire galaxies become single points of light. The internal structure of those galaxies is lost, smeared into uniformity by distance. Even within our own galaxy, there are regions so crowded with stars that individual objects blend into a continuous glow. And then there is the atmosphere. For ground-based telescopes, Earth itself becomes an obstacle. Turbulence in the air distorts incoming light, causing stars to twinkle and images to blur. Adaptive optics can compensate to some extent, but not perfectly. Space-based telescopes escape this limitation, but they face others. Size constraints, limited lifetimes, the impossibility of easy repair. Every observational platform carries trade-offs. Perhaps most importantly, the data we collect is rarely complete. Telescopes observe narrow slices of the sky, specific wavelengths, limited time windows. To build a picture of the universe, astronomers stitch together countless observations taken by different instruments, at different times, under different conditions. The resulting maps are composites, mosaics of partial views. They are immensely informative, but they are not exhaustive. And so, when we look at a map of the universe, we are not seeing a finished chart. We are seeing an evolving sketch. Regions that have been surveyed deeply stand out in exquisite detail. Others remain shallow, poorly explored, marked by uncertainty. The universe, as we know it, is unevenly observed. This unevenness introduces bias. We know far more about bright objects than faint ones. We know more about nearby galaxies than distant ones. We know more about energetic phenomena than quiet, slow processes. Our theories are shaped by what our instruments are best at detecting. There may be entire classes of objects or phenomena that escape our notice simply because they do not fit comfortably within our observational capabilities. Even when data is collected, interpretation introduces another layer of limitation. Raw measurements do not speak for themselves. They must be processed, corrected, modeled. Assumptions must be made about distances, compositions, physical laws. Small uncertainties can propagate, influencing conclusions in subtle ways. A map of the universe is never purely empirical. It is a dialogue between observation and theory. This does not mean that our knowledge is unreliable. Far from it. Modern cosmology rests on multiple independent lines of evidence that converge on a coherent picture. But coherence is not completeness. The universe is vast, and our sampling of it is sparse. Consider how much of the sky has been surveyed in detail across all wavelengths. There are still large regions that remain poorly explored, especially at certain energies. Even when surveys exist, they often trade depth for coverage, or coverage for resolution. You cannot have everything at once. Choices must be made, and those choices shape what we learn. And so, when we speak of observing the universe, we must be precise. We do not observe everything that exists within our cosmic horizon. We observe fragments, samples, representative regions. We extrapolate from those samples to the whole. This is a reasonable and powerful approach, but it rests on assumptions about uniformity and representativeness that may not hold perfectly. There is a quiet humility in acknowledging this. The universe is not something we have conquered with instruments. It is something we are slowly, carefully, learning to listen to. Each new telescope extends our reach a little further, sharpens our vision slightly more. But with each advance comes a clearer view of how much remains beyond our grasp, and perhaps that is the most important lesson of all. The limits of technology remind us that knowledge is always provisional, that every map is incomplete, that every image is a translation shaped by constraints. The universe we know is not the universe as it fully is, but the universe as revealed through the narrow windows we have managed to open. As we push against these technological boundaries, another profound limit begins to loom into view. Even if we could build perfect instruments, even if noise vanished and resolution became infinite, there would still be a wall we could not cross. A boundary not imposed by engineering, but by the early history of the universe itself. a time when light could not travel freely, when the cosmos was opaque and unreadable. Beyond that, no telescope can see, no matter how advanced. And so, our journey inevitably leads us back toward the beginning, toward the oldest light we can possibly observe, and the veil that hides everything before it. And so, as we press up against the limits of our technology, another boundary emerges, one that no amount of engineering can ever overcome. This is not a failure of imagination or resources. It is a boundary written into the earliest moments of the universe itself, a time when space was young, hot, and dense, and when light, for a brief but crucial period, could not travel freely at all. When we look out into the deepest reaches of space, we are not simply looking far away. We are looking back toward the beginning. Each photon that reaches us carries a timestamp, a memory of the conditions under which it was born. And eventually, when we look far enough, we reach the oldest light that can possibly exist for us. Beyond that point, the universe falls silent to our eyes. This oldest light is not dramatic or bright in the way stars and galaxies are. It does not come from a single place or object. It fills the entire sky, uniformly, softly, like a cosmic afterglow. It is the faint echo of a moment when the universe changed its nature forever, when it shifted from being opaque to transparent, when light was finally set free. Before that moment, the universe was a very different place. Space was filled with a dense, hot plasma of charged particles. Electrons and protons moved freely, constantly scattering photons. Light could not travel any meaningful distance without being deflected. The universe, though filled with radiation, was effectively foggy, impenetrable. There were no clear lines of sight. No images could form. Vision, in any cosmic sense, was impossible. And that's the thing, you see. When we imagine the early universe, we often picture a brilliant flash followed by expansion. But for a long time after the beginning, there was nothing to see in the way we understand seeing. The universe glowed, yes, but it was a uniform glow, a blinding brightness with no structure. Light existed, but it could not carry information across space. Then, as the universe expanded and cooled, a quiet transition occurred. Electrons began to combine with protons, forming neutral atoms. Suddenly, photons were no longer constantly scattered. Space became transparent. Light could travel freely for the first time. And the photons released in that moment began a journey that continues to this day. Those photons are still here. They fill the universe. They pass through your body right now, unnoticed, harmless, silent. Over billions of years, their wavelengths have been stretched by the expansion of space, shifted from visible light into microwaves. What was once a searing glow has become a faint whisper, just a few degrees above absolute zero. And yet, it is one of the most important signals we have ever detected. This ancient radiation is the oldest light we can possibly observe. It comes from a time when the universe was astonishingly young, long before stars or galaxies existed. It is a snapshot of the cosmos at a moment of transition, frozen and stretched across the sky, and it represents an absolute observational wall. There is nothing beyond it that we can see directly. Earlier than this moment, the universe was opaque. No telescope, no detector, no future technology can ever capture images from before this time. Light simply did not have the freedom to travel. The information is gone, not destroyed, but forever inaccessible to direct observation. This is a profound limit. It means that part of the universe's history is permanently hidden from view. We can model it. We can infer its properties from subtle imprints left on this ancient light, but we cannot see it. There will never be a photograph of the universe before this transition. No visual record, no direct witness. And yet, even this limit has given us extraordinary insight. That ancient radiation is remarkably uniform, the same in all directions to an astonishing degree. But it is not perfectly smooth. Tiny fluctuations, one part in hundreds of thousands, ripple across it. These minute variations are the seeds from which all cosmic structure grew. Galaxies, clusters, filaments, and voids all trace their origins back to these faint irregularities. In a sense, the entire visible universe is encoded in this ancient light. It is the blueprint of everything that followed. By studying it, we learn about the composition of the universe, its geometry, its age, and its evolution. We learn how much matter exists, how much dark matter, how much dark energy. We learn how space itself is shaped, but still, the wall remains. Beyond that moment, the universe refuses to speak in light. Whatever happened before is hidden behind a veil that cannot be lifted. There is something deeply humbling about this. We live in an era of astonishing scientific capability. We can detect ripples in space-time. We can measure the atmospheres of distant planets. And yet, the earliest chapter of the universe's story is closed to our eyes forever. The cosmos, it seems, keeps some of its secrets by design. This also reshapes how we think about knowledge. There is a temptation to believe that with enough time and ingenuity, every mystery will yield. But the radiation wall teaches us that some limits are fundamental. They are not problems to be solved, but conditions to be understood. The universe allows us to see only so far back and no further. And so, when we ask how much of the universe we have really seen, the answer becomes even more stark. Not only is most of the universe invisible due to distance, darkness, and expansion, not only is most matter unseen and most energy mysterious, but even the early history of the universe itself is partially erased from direct view. Everything before that transparent moment is known only through inference, through equations, through models tested against the faintest patterns in ancient light. We reconstruct a story without ever seeing its opening scene. There is a strange beauty in that. The universe invites us to listen carefully, to infer patiently, to accept uncertainty. It does not overwhelm us with clarity. It challenges us to think deeply about what can be known and what must remain beyond reach. And as we stand at this final wall of light, another thought begins to emerge, one that stretches beyond observation altogether. If even our observable universe has such firm boundaries, if its earliest moments are hidden, then perhaps what we see is only a fragment of something far larger. Perhaps our entire observable cosmos is just a small region within a much grander whole, one that extends far beyond any horizon light can ever cross. And that possibility draws us onward, beyond the edge of the visible, toward questions not just of observation, but of existence itself. And so, standing at that luminous wall of ancient radiation, we are left with a thought that feels both thrilling and deeply unsettling. If there is a point beyond which we cannot see, not because of technology, not because of darkness, but because light itself could not yet travel, then what lies beyond that boundary is not just unseen, it is unseeable. And that realization opens the door to a possibility that quietly reshapes everything we think we know about the universe. Perhaps what we call the observable universe is not the universe at all, but only a fragment of something vastly larger. You see, the observable universe is defined by a very specific condition. It is the region of space from which light has had time to reach us since the universe became transparent. That definition says nothing about what exists beyond that region. It does not claim that space ends there. It does not suggest a boundary or an edge in any physical sense. It simply marks the limit of our information. And that's the thing, you know. We have a tendency to confuse limits of observation with limits of existence. When we draw a map and label its edges, we instinctively imagine a wall beyond which there is nothing. But the universe has been teaching us again and again that this intuition is unreliable. The horizon is not the end. It is merely the end of what we can see. Modern cosmology offers several possibilities for what lies beyond. One is that the universe extends far beyond the observable region, perhaps many times larger, perhaps unimaginably so. In this view, the cosmos continues with the same laws of physics, the same kinds of structures, repeating again and again beyond our horizon. Our observable universe would then be like a small clearing in an endless forest, giving us no reliable sense of the forest's true size. Another possibility is even more radical. The universe may be infinite, not just very large, but without bound. In such a cosmos, there is no center and no edge. Every observer, anywhere, sees a horizon around them, a sphere of observability defined by light and time, and every one of those horizons encloses a different portion of the same infinite whole. In that case, what we call the universe is simply the part we happen to occupy. If that idea feels abstract, it is because our minds are not built to grasp infinity comfortably. We evolved to navigate landscapes, not endless expanses. And yet, mathematically and physically, an infinite universe remains a real possibility. Our observations do not rule it out. In fact, within the limits of what we can measure, space appears remarkably flat and uniform, properties that are consistent with an unbounded cosmos. And then there is the possibility that the universe is not only larger, but fundamentally disconnected in ways we cannot probe. Regions of space may exist that are so far removed from us, expanding away so rapidly under the influence of dark energy, that they will never exchange information with our region. Not now. Not ever. These regions would be real, physical, evolving according to their own local conditions, and yet forever beyond our causal reach. In such a picture, the observable universe becomes something like a bubble of shared history. Everything inside it can, in principle, influence everything else within it. Everything outside is separate, not by distance alone, but by the structure of space-time itself. The universe would then be a mosaic of causally isolated domains, each with its own observable horizon. What makes this so striking is that we have no direct way to confirm any of these possibilities. No telescope can peer beyond the cosmic horizon. No signal can arrive from regions forever outside our light cone. The question of the universe's true size and extent may be one of those questions that science can frame precisely, but never answer, definitively through observation alone. And yet, that does not render the question meaningless. On the contrary, it sharpens our understanding of what science is and is not. Science does not promise omniscience. It promises consistency, coherence, and humility before evidence. When evidence runs out, science does not invent certainty. It maps the space of possibilities. There is something deeply human in that approach. We stand on a small planet orbiting an ordinary star, in a galaxy that is not particularly special, and we ask questions that stretch far beyond any practical consequence. Is the universe infinite? Are there regions beyond our horizon? Are there places that will never, under any circumstances, be known to us? These questions do not change our daily lives, and yet they define our intellectual relationship with the cosmos. They also remind us of something important. Our observable universe contains everything that has ever affected us, and everything we can ever affect in return. In a very real sense, it is our universe. Its limits are not arbitrary. They define the domain of our shared cosmic story. And yet, the possibility that this story is just one chapter in a much larger book carries a quiet awe. It suggests that reality is richer than any single perspective can capture, that no matter how far we look, there may always be more beyond. This realization has a curious emotional effect. It does not diminish the value of what we know. Instead, it makes it feel precious. The galaxies we can see, the ancient light we can measure, the structures we can map, all of these exist within a narrow window of accessibility. We are, in a sense, privileged to exist at a time and place where the universe is both structured and observable. As we begin to absorb this, another thought naturally follows. If the observable universe is just one region among potentially many, if there is nothing special about our horizon in the grand scheme of things, then what about our own position within it? Are we anywhere special at all? Or are we, once again, ordinary observers, located in no privileged place, seeing the universe as it appears from just one unremarkable point within a vast and possibly endless whole. And that question gently draws us inward, away from the abstract scale of the cosmos and toward our own location within it. And so, having stretched our imagination to the very edges of what might exist, beyond horizons we can never cross, we are gently pulled back inward, toward something far more familiar, and yet just as unsettling. If the observable universe is merely one region among many, if there is nothing special about its boundaries, then what about our place within it? Where exactly are we, standing in the grand totality of everything that exists? It is tempting, almost instinctive, to imagine ourselves somewhere near the middle of things. Not necessarily at the center of the universe. We have long since given that up. But perhaps at least in a region that matters, a place that is in some subtle way privileged. And yet, once again, the universe offers no such comfort. Our home, Earth, is a small rocky planet orbiting a fairly ordinary star. That star is one among hundreds of billions in a single galaxy. And that galaxy, the Milky Way, is not especially large, not especially dense, not especially unique. It drifts through space as one member of a small group of galaxies, itself located on the outskirts of a vast cosmic structure. We are not near the center of our galaxy. We do not orbit close to its core, where stars are packed tightly together and gravitational forces dominate. Nor are we at its extreme edge. We reside in a quiet suburb, a calm spiral arm, far enough from violent regions to allow stability, but not so far that we are isolated from the galaxy's material. This location is convenient for life, but it is not cosmically distinguished. And that's the thing, you know. Every time we have searched for a special position, the universe has gently but firmly corrected us. The Earth is not the center of the solar system. The sun is not the center of the galaxy. The galaxy is not the center of the universe. At every scale we find ourselves offset, ordinary, one example among many. This pattern is not accidental. It reflects a deeper principle that has guided modern cosmology for over a century. The idea that there is nothing special about our location in the universe, that the laws of physics are the same everywhere, that what we observe from here would look broadly similar to what any other observer would see from their own vantage point. This principle has been remarkably successful. It allows us to generalize from limited observations. It allows us to build models of the universe as a whole, but it also carries an emotional weight. It asks us to accept that we are not central to the cosmic story. From a human perspective, this can feel unsettling. Our lives are full of meaning, memory, intention. We experience the world from a center that feels absolute. Everything radiates outward from our own consciousness. And yet, the universe does not acknowledge that center. It does not organize itself around us. It simply unfolds according to its own laws. And still, there is something quietly beautiful in this realization. To exist in an unprivileged position is not to be insignificant. On the contrary, it means that our experience is not unique, that what we see here is a fair sample of what exists elsewhere, that the universe we study is not a special case, but a representative one. Our smallness becomes a strength. From an ordinary location, we can infer extraordinary truths. Consider again our position within the observable universe. We are not near its edge. We are not near any identifiable center. Every observer, wherever they are, sees themselves at the center of their own observable universe, surrounded by a horizon defined by light and time. This is not because anyone is special, but because the universe expands uniformly. Perspective creates the illusion of centrality, but it is an illusion shared by all. This has a curious consequence. There is no cosmic address you could write down that says, "Here is the middle of everything." There is no privileged vantage point from which the entire universe could be seen. Every view is local. Every observation is partial. And so, when we look out into space, we are always looking from somewhere, never from everywhere. The solar system itself reinforces this lesson. Our planet orbits at a distance from the sun that allows liquid water to exist. This has often been described as a special location, and in a narrow sense it is. But when we examine the galaxy as a whole, we find that such regions are not rare. There are countless stars with planets, countless environments where conditions may be right for complexity to arise. Our circumstances are fortunate, but not unique. The universe does not appear to be fine-tuned for us personally. It appears to be vast enough that many variations play out simultaneously. Some regions hostile, some benign, most indifferent. And that indifference is perhaps the hardest thing to accept. The universe does not seem to care whether we are here to observe it or not. Its expansion would continue. Its galaxies would form and fade. Its stars would burn and die, whether or not any conscious beings were there to notice. And yet, here we are, tiny, brief, fragile, made of the same atoms forged in ancient stars, capable of looking back across billions of years and reconstructing the story of the cosmos. That in itself is extraordinary. Our limited perspective does not diminish the wonder. It sharpens it. Because from this small point in space and time, we have managed to glimpse patterns that stretch across the observable universe. We have learned that our galaxy is not central, our star not special, our planet not unique. And instead of making us feel lost, this knowledge connects us to everything else. We are not separate from the universe. We are expressions of it. The atoms in your body were assembled in stellar furnaces long before the Earth existed. The laws that govern your thoughts are the same laws that govern galaxies. There is no boundary between us and the cosmos, only scale. And scale, as we have seen again and again, is the great humbler. When we place ourselves honestly within the totality of what we know, we find that our perspective is astonishingly limited. We occupy a tiny region of space. We exist for a fleeting moment in cosmic time. We see only a narrow slice of reality, filtered through biology, technology, and history. And yet, that slice has been enough to reveal something profound, enough to show us that the universe is vast beyond imagination, enough to show us that most of it is unseen, enough to show us that we are not central, not privileged, not special in position, but perhaps special in another way. Because even with all these limitations, even with our constrained viewpoint, we have managed to ask the right questions. We have learned to doubt our intuitions. We have learned to measure carefully, to reason patiently, to accept uncertainty. And that brings us to a final quiet realization, that the value of knowledge does not lie in completeness, but in depth. That understanding does not require total access. That even a small window, if opened with care, can reveal astonishing beauty. As we step back from our place in the universe, recognizing how small and uncentral it truly is, we are left with a paradox that feels almost comforting. We have seen very little, but what we have seen is enough to transform how we understand existence itself. And that thought gently carries us toward the final reflection, not about how much we have seen, but about why even this limited glimpse has been enough to leave us in awe. And so we arrive at a realization that feels quieter than the revelations that came before, but perhaps more profound than any of them. After tracing the limits of light, matter, energy, space, time, and technology, after acknowledging how small our vantage point truly is, we are left with a simple and almost disarming truth. What we know about the universe is only the surface, and yet, astonishingly, even this surface is enough to fill us with wonder. Everything we have uncovered so far represents only a thin skin of understanding stretched over an unfathomably deep reality. We have learned how big the observable universe is, but not how big the universe truly is. We have mapped galaxies, but not the vast emptiness between them. We have detected dark matter through its gravity, but not its nature. We have inferred dark energy from cosmic expansion, but not its essence. Again and again, knowledge stops just short of explanation. And that's the thing, you see. The universe does not reveal itself all at once. It offers hints. It allows patterns to emerge. It gives us enough information to build coherent models, but never enough to close the story. Each answer seems to open several new questions, each more fundamental than the last. From one perspective, this could feel frustrating. After centuries of observation and theory, how can we still know so little? How can the most dominant components of reality remain mysterious? How can the universe be so vast, and our grasp of it so small? But there is another way to see this, a gentler way. One that recognizes that knowledge does not need to be complete to be meaningful. The fraction of the universe we understand, small as it is, has already transformed our view of existence. From this thin layer of insight, we have learned that the universe is ancient, evolving, structured, and governed by elegant laws. We have learned that space and time are woven together, that matter can be invisible, that emptiness can shape reality, that the cosmos is dynamic, not static, creative, not inert. This is no small achievement. Consider what it means that we can look at the night sky and know that the faint glow we see is billions of years old, that we can read the chemical composition of stars from their light, that we can trace the growth of galaxies from tiny fluctuations imprinted on ancient radiation, that we can reconstruct the history of the universe with nothing more than photons, equations, and patience. All of this has been done from a single planet, orbiting a single star, in a galaxy that is not particularly special. And yet, even with all this knowledge, the universe continues to challenge us. It refuses to be fully known. It resists closure. It keeps its deepest secrets just out of reach. And perhaps that is not a failure of science, but its greatest gift. Because the unknown is not an obstacle. It is a driving force. The fact that we do not understand dark matter has inspired generations of experiments and theories. The mystery of dark energy has forced us to question our understanding of gravity itself. The limits imposed by the early opaque universe have pushed us to develop new ways of probing cosmic history indirectly. Every gap in understanding becomes a source of momentum. Science thrives not on certainty, but on curiosity. And there is something deeply human in this relationship with the cosmos. We are not passive observers. We are participants in an ongoing dialogue with reality. The universe reveals a little. We respond with questions. It answers some and withholds others. The conversation continues. It is also worth reflecting on how extraordinary it is that such a small amount of knowledge can carry such emotional weight. Even knowing that the observable universe is only a fragment, that most of reality is unseen, does not diminish the beauty of what we can see. If anything, it amplifies it. A single galaxy, understood in its context, becomes a miracle of structure and time. A single star becomes a laboratory of physics. A single photon becomes a messenger from deep history. The surface, once understood, reveals depth. And so, perhaps the true measure of understanding is not how much we know, but how deeply what we know reshapes our perspective. The universe we have glimpsed so far is enough to humble us, enough to remind us that we are not central, not privileged, not essential to the cosmic story, and yet enough to show us that we are connected to everything else in a profound way. We are made of the same particles that fill the cosmos. We obey the same laws. We are subject to the same expansion of space and the same flow of time. The universe is not something outside of us. It is something we are embedded within. And in that sense, even incomplete knowledge carries meaning. To understand that we know little is itself a form of understanding. There is a quiet wisdom in accepting limits, in recognizing that some questions may never be fully answered, that some aspects of reality may always remain beyond direct access. This does not weaken science. It grounds it. It keeps it honest. And yet, despite these limits, the universe continues to invite exploration. Each generation builds better instruments, sharper theories, more refined questions. Each generation opens a new door, even if only slightly, and peers into a deeper layer of reality. What lies beyond that door may not be clarity. It may be another mystery, but that too has value. Because the act of seeking, of wondering, of listening to the universe with humility is itself part of what it means to be human. As we stand here, knowing that we have seen only the surface, we might feel small. But perhaps we should also feel grateful. Grateful that the universe is rich enough to sustain endless inquiry. Grateful that it does not give itself away too easily. Grateful that there is always more to learn. The unknown is not a void. It is a horizon. And so, having accepted that our understanding is limited, that our view is partial, we are ready to arrive at the final reflection, not one of despair at how little we have seen, but one of quiet awakening. Because even this small glimpse, this thin slice of cosmic truth, has already been enough to change how we see ourselves, our world, and our place in the vast unfolding story of existence. And so, from that quiet awakening, another layer of reflection begins to unfold, softer in tone, slower in pace, almost as if the universe itself is inviting us to sit with what we have learned rather than rush onward. Because once you truly accept that we have seen very little, and yet have seen enough to be transformed, a new kind of question emerges. Not what else is out there, but what this realization does to us. You see, for most of human history, the night sky was a ceiling, a beautiful one certainly, scattered with lights and patterns, but still a ceiling. It framed our myths, our calendars, our fears, and our hopes. And then gradually, almost imperceptibly, it became a window into depth, into time, into processes so vast that language itself began to strain under the weight of them. What is remarkable is not just that we discovered how small we are, it is that we learned to live with that knowledge, to carry it without despair, to let it humble us without diminishing us. Because the universe does not make us small by comparison, it makes us precise. When you realize that the vast majority of reality lies beyond your senses, beyond your instruments, beyond even your capacity to imagine fully, something curious happens. You stop demanding that the universe revolve around you. You stop expecting it to be tidy, complete, or narratively satisfying. Instead, you begin to listen. And that's the thing, Science at its best is not an act of conquest. It is an act of attention. It is the disciplined practice of noticing what the universe is willing to reveal, and being honest about what it is not. We often celebrate discovery as though it were about accumulation. More data, more images, more measurements. But the deeper transformation comes not from knowing more facts, but from learning how to think in the presence of uncertainty, from learning how to stand at the edge of knowledge without rushing to fill the silence. The realization that most of the universe is unseen does not close doors. It opens a different kind of curiosity, a slower one, a more reflective one that asks not only how things work, but why we are compelled to ask at all. After all, the universe would continue exactly as it is if no one were here to observe it. Galaxies would still form. Space would still expand. Dark matter would still sculpt invisible structures. Dark energy would still push everything apart. None of it depends on us. And yet, here we are, a species capable of reconstructing the history of the cosmos from faint traces of light, capable of imagining infinities, horizons, and epochs long before our planet existed. That capacity is not required by the universe. It is something that emerged within it. Perhaps that is where the quiet significance lies. We are not important because we are central. We are important because we are conscious. Because the universe, in at least one small corner of itself, has become aware of its own vastness. That awareness does not grant us power over the cosmos. It grants us responsibility toward knowledge, toward humility, toward wonder. There is a temptation, especially in an age of extraordinary technology, to believe that ignorance is a temporary inconvenience, that every mystery is simply waiting its turn to be solved. But the story of the universe suggests otherwise. It suggests that mystery is not a flaw in our understanding, but a fundamental feature of reality. Some things are hidden by distance, some by time, some by the nature of light itself, some by the limits of human cognition, and some perhaps because the universe does not offer them to be known. Learning to live with that is not a resignation. It is a maturation. It allows science to remain open-ended. It allows philosophy to remain relevant. It allows wonder to survive success. Because once you believe that everything important has already been seen, curiosity withers. The night sky becomes decoration rather than invitation. The universe becomes a solved problem rather than an unfolding story. But we are nowhere near that point. In truth, we are still at the beginning of our relationship with the cosmos. We have only just learned how to read a few of its languages: light, gravity, motion, radiation. Each one has opened a new chapter, and each has revealed that there are far more chapters left unread. And perhaps that is why the universe feels so profoundly beautiful once you truly grasp how little we know. Beauty does not require completeness. It requires depth. It requires layers. It requires the sense that there is always more, beyond the next horizon. When you look up at the stars with this understanding, the experience changes. You are no longer just seeing distant suns. You are seeing limits, boundaries, messages that have traveled for unimaginable spans of time just to reach you. You are seeing evidence of both connection and separation, of belonging and isolation. The light touches your eyes, but its source may no longer exist. The structure you infer may be shaped by forces you do not understand. The space between you and that light is mostly empty, mostly dark, mostly unknown. And yet, that moment of seeing is real. It is intimate. It is shared by no one else in exactly the same way. Perhaps this is the final gift of recognizing how little we have seen. It returns the universe to the present moment. It reminds us that every observation is fleeting, that every glimpse is a temporary alignment between curiosity and circumstance. We are here now, in this era, with these tools, with these questions. Future generations will see differently. They will inherit a universe slightly more expanded, slightly more distant, perhaps quieter in some ways, richer in others. They will open doors we cannot yet imagine, and they too will confront limits. That continuity matters. It tells us that knowledge is not a destination, but a process passed forward in time. So when we say that we have seen very little of the universe, we are not confessing failure. We are acknowledging our place in a much longer story, one in which each generation sees a little further, understands a little more, and learns again and again that the universe is deeper than it first appears. And as that understanding settles in, gently, quietly, it carries us toward the final horizon of reflection, not about what the universe is made of, or how large it is, but about what it means to be a small, fleeting part of something so vast, and still feel that listening to it is one of the most meaningful things we can ever do. And so we find ourselves at the quiet edge of this long journey, not at a place of final answers, but at a place of clarity, a clarity that does not come from knowing everything, but from finally understanding the shape of our ignorance. We have seen very little of the universe, and yet, what we have seen is enough to awaken something profound within us. When you gather all of this together, the limits of light, the invisibility of most matter, the dominance of unknown energy, the vast emptiness between galaxies, the boundaries of time itself, a single truth becomes impossible to ignore. Humanity has never truly seen most of the universe, not even close. The overwhelming majority of reality exists beyond our direct perception, beyond our instruments, beyond even our most careful theories. And that might sound like a confession of weakness, but it is not. It is a statement of perspective. because the beauty of science has never been in its claim to completeness. It has always lived in its willingness to confront the unknown honestly, to say, here is what we see, here is what we infer, and here is where the darkness still remains. The universe does not mock us for our limitations. It simply continues to exist on its own terms, vast, patient, indifferent to whether it is fully understood, and somehow that indifference is freeing. It removes the burden of finality. It allows knowledge to remain open, dynamic, alive. Each generation of humans opens a door just a little wider. A new telescope, a new theory, a new way of listening to the cosmos. And behind each door, the universe does not reveal a tidy conclusion. It reveals more depth, more structure, more mystery. That is not a failure of progress. It is the nature of reality. When we look back across the long arc of discovery, from the first realization that Earth is not the center, to the understanding that our galaxy is one among countless others, to the recognition that even the observable universe may be only a fragment, a pattern emerges. Knowledge does not shrink the universe, it expands it, and with that expansion comes humility. We are small. Our planet is small. Our lifetime is brief. Our window of observation is narrow. And yet, from within that narrow window, we have managed to reconstruct a story that stretches back billions of years. We have learned that the atoms in our bodies were forged in ancient stars, that the light touching our eyes tonight began its journey long before our species existed, that the space between galaxies is shaped by forces we do not yet understand. That alone is extraordinary. It means that even limited knowledge can be transformative, that even a tiny fraction of understanding, placed in the right context, can change how we see ourselves entirely. The realization that we have seen very little of the universe does not diminish human curiosity. It dignifies it. It places it within a larger narrative, one where exploration is not about domination or completion, but about relationship. We are not here to conquer the cosmos. We are here to listen to it. And listening, truly listening, requires patience. It requires silence. It requires the willingness to accept that some answers will come slowly, and some may never come at all. The universe speaks in faint signals, in ancient light, in subtle motions, in delicate patterns that emerge only after careful thought. It does not shout, it whispers, and only those who learn to quiet their expectations can hear it clearly. There is also a deeply human comfort hidden in this realization. If the universe were fully known, fully mapped, fully understood, curiosity would have nowhere to go. Wonder would collapse into certainty. The night sky would become a solved problem, rather than an invitation. But that is not the universe we inhabit. Instead, we live in a cosmos that resists closure, that offers just enough understanding to inspire awe, and just enough mystery to sustain it. A universe that remains vast not only in size, but in meaning. And perhaps that is why even a small glimpse is enough. Enough to remind us that we are part of something older and larger than ourselves. Enough to place our personal struggles within a broader context. Enough to soften our certainty and sharpen our questions. When you truly absorb how little we have seen, the everyday world changes slightly. Time feels different. Distance feels deeper. The night sky becomes less familiar and more intimate at the same time. Each star is no longer just a point of light, but a story intersecting with your own for a brief moment. You begin to sense that existence is layered, that what appears solid and immediate is resting atop vast structures of unseen processes. That reality is not just what is close and bright, but also what is distant, dark, and subtle. And in that awareness, something remarkable happens. The universe stops feeling cold. It stops feeling empty. Instead, it feels alive with possibility. Not because it is designed for us, but because we are capable of responding to it. Our capacity for wonder is not diminished by our smallness. It is amplified by it. We are fragile observers in a universe that does not require observers. And yet here we are, asking questions that stretch across time and space, building instruments to catch ancient light, writing equations that describe realities we will never directly experience. That act alone carries meaning. It tells us that value is not measured by scale, that significance does not require centrality, that even a fleeting consciousness, arising briefly in one corner of the cosmos, can reflect on the whole. And so, when we say that we have seen very little of the universe, we are not closing a door. We are opening one inward, toward humility, toward patience, toward a deeper appreciation of the unknown. Because the unknown is not an absence, it is a presence we have not yet learned how to meet. Every generation will stand where we stand now, aware of what has been learned, aware of how much remains hidden. And each generation will add its own small contribution, its own new way of seeing. No single era will finish the story. And that is as it should be. The universe is not a puzzle with a final piece. It is a landscape through which understanding slowly travels. Each insight is a step, not a destination. We have seen very little, but we have seen enough to know that the universe is beautiful beyond measure. Enough to know that it is deeper than our intuition. Enough to know that curiosity itself is one of the rarest and most precious phenomena it contains. And as we sit with that realization, quietly, gently, there is no need for an ending, only a continuation, a sense that the story does not conclude here, but flows onward, carried by questions, by wonder, by the simple human act of looking up into the darkness and choosing to listen.